Hello, Oki. It's so great to be here with you guys today. And welcome to the Flagstaff Festival of Science. This is Nistunetanaku omahkestowakaki. Hello, my name is Walking Raven Woman. My government name is, of course, Mariah Gladstone. And I'm super excited to share information with you guys today to hopefully be a resource, hopefully get you thinking about this vast context of Indigenous food science knowledge, food systems knowledge, ecology, and of course, culture and tradition. But in order to start and frame that and why it's so important to talk about these things, I want to bring us back in time and start with a little baby history lesson. So I'm going to take us back to when the United States was 3 years old, and our first president, of course, George Washington, wrote orders for Major General Sullivan to march against the Haudenosaunee Confederacy. The Haudenosaunee are the Iroquois Confederacy, as they are sometimes known, are the Six Nations in present-day New York, Ontario area. And he wrote very explicitly to target their food systems, to burn their fields and their villages and their seed banks and their gardens so that they would not be able to plant more. This campaign was considered incredibly successful. The Major Sullivan and his armies burnt 130,000 bushels of corn. If you don't speak in bushels, that's about 7.3 million pounds of corn, and about 44 villages were burnt. Unfortunately, of course, these villages were then facing starvation, lost corn, and of course, hundreds of thousands of pounds of other vegetables as well. And so what happened, actually, interestingly enough, was that this coincided with the emergence of a cicada cycle. And so cicadas actually emerged from the ground in that summer, and the people were able to gather tons and tons of cicadas to get them through that next winter until they were able to plant again. Unfortunately, this strategy, being considered effective by the US government, was employed in different methods as settlers pushed farther to the west. And controlling Native people by targeting our food systems was a strategy that was employed in different ways. It was the 1850 Commissioner of Indian Affairs report that wrote, "It is cheaper in the end to feed the whole flock for a year than to fight them for a week." Essentially saying, if we destroy Native people's ability to feed themselves and force them to depend on government rations, then we can force them to sign documents, do whatever, control movements of Native people. They will no longer militarily resist us. No one's gonna bite the hand that's feeding them, right? And so it was this goal that led to mass extermination campaigns of bison on the prairies. And I'm sure you guys have probably seen this picture at one point or another in a textbook or a museum or something. This picture is interesting to me, but I think it's a very visual demonstration of mass casualties of buffalo lives lost. Conservative estimates have pre-contact buffalo populations close to 30 million, but there are estimates that some anthropologists, historians, and archaeologists have as high as 60 to even 75 million. By the time my home state, Montana, became a state in 1889, those numbers were less than 1,000. And so tribes that depended on buffalo for food, clothing, shelter, tools, ceremony, other resources, lost all of that. We lost our Walmart, essentially. What's interesting to me about this picture is, yeah, this is a big pile of bison skulls. But most folks that have studied this to any extent recognize that many times those bison were shot on the prairies and left to rot. Though this was also coinciding with the start of the Industrial Revolution, and the hides were often taken to be used as machine belts. This was before vulcanized rubber was the machine belt material of choice. So they were using bison hides. The rest of the animals, bones, meat, everything was left to rot on the prairies. Later then, Native people were paid a couple of pennies to go and collect as many bones as they can and bring them back to shipping locations. So this is why we end up with giant pictures of piles of bison skulls, is because those bones were later picked up. Why did they pick up all those bones? It was because those bones were used as a resource to be ground down, to be made into bone china, but also to be used as fertilizer. And that was one of the primary uses of these bones. So if you guys have ever put bone meal in a garden as a fertilizer, that's what this was being used for. So what's interesting to me about this picture is, yes, as a Blackfeet person, this speaks to a loss of our massive source of food and resources, but also, as a Cherokee person, as a person who comes from a rich agricultural tradition, this is also speaking to the loss of soil fertility that was occurring on the Great Plains after about a generation or so of tilling, and monoculture agriculture was taking place on the prairies. So I think that this is interesting because it ties a couple of different things together. So that's a lot of history background condensed into about 2 slides. But the result was, of course, that Native people were forced to depend on rations. The rations were boxes of shelf-stable food that was cheaply produced, designed to be transported long distances, and keep people alive. It was not food that we traditionally had in our diets. It was things like wheat flour, maybe some beef, and we had to figure out how to work with these boxes of food. Oftentimes, these food boxes didn't always arrive in the best condition, and sometimes this flour would be gross and moldy or have bugs in it and be already this weird flavorless dust that we weren't used to eating. And so Native people learned how to work with it, and we had to cook that flour into something that was food safe. And so we developed, of course, we utilized frying technology so that that flour was heated to a temperature that was high enough to kill those pathogens and make it food safe. And it's from this time, of course, that we get fry bread. And so fry bread, while not an indigenous food in that it's not present in our historical antiquity, it is a traditional food because it's a food that helped us survive, and it's part of our history. So in that way, it's a traditional food. But, of course, along with this and this transition to colonial food systems, we get the diet-related illnesses and all of the things that come with that. And we also lose our self-sufficiency, our food sovereignty. And folks may have heard that term, may have had definitions for that term. I define food sovereignty as the abilities of people to feed themselves. There's a bigger definition which says it is the right of people to healthy, affordable, culturally appropriate food, harvested through ecologically sound and sustainable methods, and the right to govern those food systems. So big definition, but it is the ability of communities to feed themselves in the way that are best suited for the land and the peoples and the environment. And that's what I want to jump into. So I love this graphic. This graphic comes from NATIF's, North American Traditional Indigenous Food Systems. And you can find this graphic on their website at natifs, natifs.org, because it breaks down indigenous food systems into more than just the food. Right? We can go into a grocery store and I can point to you the foods that originated in North America and South America, and we can talk about indigenous foods in isolation as just the foods themselves. But indigenous food systems and all the science around them is so much more than just the foods. So for example, in that plant quadrant, it is about the planting methods, it's about the cultivation methods, it's about the seed saving, it's about the specific breeding for characteristics of those plants. And it's, of course, about plant identification in the wild. You guys ever go out to a plant walk or something and someone tells you, this plant is edible? Okay, that's cool. What part of that plant is edible? When do I harvest it? How much can I harvest without harming the overall population of this plant? How do I cook it? Are my kids going to eat it? What's it going to taste like, right? There's all these other questions about that plant and all the plant knowledge that's around that. And that's really important to talk about. Same thing with animal knowledge. If you are eating animals, what time of the year are you hunting those animals or butchering those animals? How do you honor that animal's life? By utilizing every single part of that animal. How are you raising the animal, or where are you going to make sure that that animal is harvested ethically? All of these things are very important in the context of animal harvesting tradition. Same thing, how do you make bone broth, utilizing the bones? How do you make tallow so that you have cooking oil or skincare or whatever you're utilizing tallow for? How do you skin an animal so that there's no holes in the hide and you can actually use that to make clothes or footwear or anything else? So there's lots of other tertiary knowledge that's going along with this stuff. And then I like this because it also points out the resources of the land. Thinking about the air, thinking about the geology of the landscape as resources. I come from Montana. We also have very dry air, like Arizona, and that's a resource for us. I went to grad school in upstate New York. Summers are very humid. And in Montana, when we go hunting, if I want to, I can cut all of that meat into thin strips and I can hang it on little strings in my living room above my wood stove, and I can dry that meat out and make dry meat, and it's food safe and it's like super dry jerky, right? And I don't have to use my freezer space because we have really dry air, and when you get the wood stove turning, I'm turning that basement room into a big dehydrator. Same thing, we dried out tons of berries. That was our method of preservation. Bacteria thrive in water, so if you eliminate the water, you have a food-safe, preserved food, but is also highly transportable. And as Blackfeet people that were moving around on horseback, or before that in the dog days with travois, we wanted things that were lightweight that we could pack and take long distances. So thinking about the humidity of the air as a resource for us. But not everyone has low humidity. So in the eastern United States, there was a lot of smoking techniques that were utilized in order to preserve that food, in order to smoke it, in order to salt preserve that food, because there were massive salt deposits in certain areas. And thinking about the technology, what are the resources that we have? Some tribes that had access to things like obsidian became very rich off of that geological resource because it was used because of the specific crystalline structure to make arrowheads and knives and other things that were essential for hunting and cutting up foods. So very important resources from the landscape. And then, of course, finally, this indigenous wisdom, the stories that go along with these foods, how we got these things. Sometimes we have creation stories for our foods themselves. Sometimes we have artistic knowledge that goes with those foods, using sumac as a dye, using sunflower seeds as dyeing technology, right? All of these things that are tertiarily related to our food systems, but are really essential to the overall big picture. For Blackfeet people, we used porcupine quills to do embroidery on our outfits to decorate them. So there was all these different things that go along with us. So I really like this graphic because it digs into more than just recipes. I love recipes, that's what I do, but there's also so much more that are part of the bigger recipe picture of indigenous food systems. So let's jump in. You guys saw the lovely ballet. Thank you so much, because that was incredible, and there was a Three Sisters song. Did you guys catch it? So Three Sisters, I'm starting simple. A lot of people have heard of the Three Sisters before, so I'm not gonna bore you guys with too many of the big picture details. I want to talk about the little things. So Three Sisters, of course, refers to corn, beans, and squash. Corn is the eldest sister, of course. She's planted first, and so that way by the time that you plant beans and squash, that beans have a structure to use corn, the older sister, as a trellis, to grow up tall, to hang on to. Of course, beans have a floppy spine, can't really stand up on their own, but they are a legume, which means that they have root nodules that contain nitrogen-fixing bacteria that are capable of pulling the nitrogen out of the air and putting it into the soil where the other sisters have access to it. They're fertilizing the soil system through their presence. And squash, like pumpkins or zucchini or butternuts or all these different squash varieties that we have, spread out all over the ground. If you guys plant squash in your gardens, they probably take over, and they shade the ground. They prevent evaporative loss from the soil, which means you don't have to water the system quite as much. And they also have these little irritating hairs on their stems. And certain bugs don't like to crawl on those little irritating hairs. So they guard the system as well. And together, they balance each other out. Like siblings are, they're very different. They have different personalities. They need different things, but they support each other. So we also use three sisters, of course, as a metaphor for how we can support each other in our workplaces or our families or interpersonal relationships or whatever that may be. But the three sisters are also very cool because when eaten together, they form a complete protein with all of the essential amino acids. There's also research that was done by Jane Mount Pleasant at Cornell University looking at crop yields of Three Sisters planting systems. So she used traditional Haudenosaunee methods because that's her community, and she did traditional Haudenosaunee mound planting. And she looked at crop yields based on calories per hectare and protein per hectare of planting with the traditional Three Sisters or planting a field of all corn, all beans, or all squash. So you guys can see this graph behind me. You can see that Three Sisters produced, I put the protein graph up here, produce more protein per hectare. Oh, look, I have a laser beam. Okay. So they produce more protein per hectare than corn, beans, or pumpkin. You can see pumpkins divided into two sections. They looked at the pumpkin seeds and pumpkin flesh. So just so you know how that's all broken down, which is really cool because, of course, it's interesting to see just efficient utilization of land space. And planting with the Three Sisters was not only producing more, but also it was not draining the soil in the same way that planting monocultures year after year does. So this was really cool. I also think that this is cool because the ways in which people were eating these foods are not typically the ways that we consume them on a day-to-day basis today. Most of these foods were being consumed at the very end after the seeds had matured. So instead of eating sweet corn, the corn was left to dry and was turned into dry corn. We'll talk about that in just a second. I want to talk about something that's sometimes referred to as the fourth sister. You guys have such beautiful wild sunflowers around town. And wild sunflowers and sunflowers by themselves are a great example of indigenous plant breeding knowledge, because wild sunflowers occur naturally. That is a plant that is native to North America. But native people, native farmers, decided they liked those seeds, but they wanted them to be bigger because native sunflowers have itty bitty seeds. And so they found the sunflowers with the biggest seeds, and they crossbred those varieties. And over generations, they developed sunflowers with great big flowers with big edible seeds that you guys are familiar with today. They also developed plants like this guy in the middle. This is the Hopi black dye sunflower. So they bred those sunflowers specifically to have black shells to their seeds. And that could be used for dyeing technology. So for dyeing wool and fibers and even porcupine quills was utilizing technology over time to create cool dyes. So this is a really good example of indigenous plant breeding technology. But I call this the fourth sister because in many cases, tribes that were planting the Three Sisters also planted sunflowers. But sunflowers have a tiny problem with being planted in the mounds. They emit an herbicide through their root system. It's a subtle herbicide, but it harms other plants. So this sister is a border plant. She hangs out on the outside of the farm. She hangs out on the edges to prevent weeds from coming into the garden or the farm. And she has beautiful sunflowers, flowers that attract pollinators to the garden. So she is both attracting pollinators like butterflies, like moths, like bees, of course, and all of these other wonderful pollinators that we have with these big, very visible flowers. And she's preventing weeds from coming into the garden. But she cannot act as a support system for beans because of that herbicide that's emitted through the soil. If you guys are familiar, folks from the Midwest may know black walnut trees. Black walnut trees do the same thing, and they kind of poison the ground around them. So she's another sister, but she has to hang out in the background sometimes. All right, I wanted to talk about this concept because corn is incredibly inefficient in the way that we consume it today. We're not getting a lot of nutrients from corn. In its raw state, corn is just not very digestible to our bodies. And Native people had empires that were built off of corn because they developed a technology in order to make the corn digestible. So this technology, this word actually comes from the Aztec language. So it's pronounced closer to nixtamalization, but we can say nixtamalization. That word tamal, you guys may recognize because tamales, of course, comes from that as well. And nixtamalization is the process of treating dried corn, mature corn seed that is shelf stable with all moisture removed, with a highly alkaline solution. So think acids and bases. We're raising the pH up high, very basic, and we're cooking this corn in a big, basic bath. And that has the effect of chemically removing the hull of the corn and turning the bound niacin into free niacin so our bodies can absorb it. There's also actually really cool research. Did I put it up here? Yes, I did. So it increases the bioavailability of the calcium by 200%. So that research actually came from Dene folks that were doing research with juniper ash and blue corn mush and the advantage of adding those juniper ashes. Tribes, no matter where they were adding ashes to water, and that's what was raising the pH. So real traditional cooking, you guys look at like ashes to water. Ashes add a lovely smoky flavor as well. And they're very high in calcium. And they're making this corn digestible. Now, what you'll see people use is, of course, culinary lime, or cal, and that does exactly the same thing, but without the lovely smoky flavor. I was at a high school in Montana speaking to an AP chemistry class, and they decided that they wanted to develop an acids and bases lab using different types of wood ashes, but also culinary lime, and evaluating flavor profiles and how the pH was going to be raised by adding, X amount of wood ashes. What do you need to get it to equal the same pH? And it was a hominy making workshop because that's what happens when you do this. It transformed dried corn into hominy. Then you have a lovely, soft, digestible corn made, of course, with that seed where the sugars have then been converted to starches. So this is now a very efficient grain for our bodies to consume. And if you grind that up, you get masa. Well, actually, if you grind it up coarsely, you get grits. If you grind it up very finely, then you get masa. And you can make tortillas, you can make tamales, you can make all of these different foods that are made from that very digestible corn. So, let's rewind. Columbus showed up. Columbus took corn back to Europe. And corn started to be grown in different communities. It took off really in the 1500s, late 1500s, especially in Eastern Europe, Spain, Italy, and actually Egypt as well. But in those locations, they had massive grinding technology. They had water-powered mills and they had wind-powered mills. So it was relatively easy for them to throw dried corn into one of these mills and come out with cornmeal. Cornmeal has not gone through the nixtamalization process. So it's not very digestible. You can bake with it, you can work with it, you can cook it in water, and it turns into polenta, and your body can consume it, but you're not getting a lot of the nutrients. And so when peasant communities especially started transitioning to diets that were made very heavily of corn, they weren't getting the nutrients from it. They're getting some calories, but no niacin, not a lot of calcium. And so you start to see in the late 1500s, epidemics of pellagra among peasant communities. Pellagra is a niacin deficiency. And one of the symptoms of pellagra, there are several, but one of the most severe and very noticeable symptoms is that if you go out in the sunlight, your skin will start to burn. It will turn like red, like the most intense sunburn that's taking place. And so people that get pellagra, of course, this is the 1500s. People don't understand nutrient deficiencies. Instead, they're doing what they can to avoid this symptom, and so they're avoiding the sun. They're putting on big hoods if they're going out during the day, covering every square inch of skin, and doing their chores at night if they can. And so it's from this time period that we also get the origination of the vampire myth. So happy spooky season. Corn, treatment of corn, indigenous knowledge, it's all connected to vampires. But it is really interesting because this process is something that was so critical and the reason that we were able to have entire civilizations that were built off of corn as the predominant food and the grain that was taking place. So cool knowledge that you guys will hopefully never forget. Okay. I wanted to talk about traditional land stewardship methods too, because this is something that's super important to me. I'm trained as an environmental scientist. I look at human food systems, environment interactions, all of that. And I love talking about fire because I come from a community similar to this where fire season can always be something that we look at with a lot of danger, skepticism. We never know what's going to happen during fire season. We're always looking for some rain, some moisture, and then even if the fires are far away, we're always dealing with smoke and all of these other things. But it's also interesting to look at fire as a resource. And that's what Native people have been doing, is using fire as a tool. So I love this concept of good fire. I've also heard the term cultural burning used. And no matter where you look on the continent, there are examples of Indigenous people utilizing fire as a tool for managing the landscape. So we're going to throw out this concept of wilderness as untouched spaces, but we're instead going to look at the landscape as places that have been managed for 14 to 18,000 years very intentionally. And one of those was by fire. So this is actually a Charlie Russell painting. Charlie Russell is a Western artist that moved to Montana. The Blackfeet people actually adopted him. He moved to Montana when he was 16 years old from St. Louis. And he spent a lot of time around the Blackfeet. He learned a sign language so he could communicate with our Blackfeet people. He was camped with our people one year, and he ended up splitting the back of his pants open. And he asked our elder women, he said, "Can you give me something to patch my pants with?" And they gave him a piece of white buckskin. So he had a piece of white buckskin right on his butt. And so we adopted him, and he was given the name Awakas, which was whitetail. So Charlie Russell, he's Blackfeet now, and I'm claiming him, but he was a really well-known Western artist for his time. And I love this picture because it's an image of two Blackfeet men setting fire to the prairie. And it was because of these prairie fires that we would intentionally set that would help us tend the landscape. There are separate peer-reviewed studies demonstrating that elk antelope, bighorn sheep, deer, moose, and mountain goats all will preferably graze land that has been burnt within the last year than any other land around it that has not been. So there's a couple of things that happen when you burn off this old landscape. In the end of the year, when it's fall and the grass is browning up, you burn it off when you start to get those fall rains that come in, and it burns off a lot of that leaf litter, we call it. You have a big blackened patch of prairie. By the way, if you walk through a big blackened patch of prairie with your moccasins, it turns the bottom of your moccasins black. And we got the name Blackfoot because of intentional land management practices. But what happens is you also burn off a lot of the shrubland, whether that be sagebrush, whether it's shrubby cinquefoil, wild roses. You burn off a lot of that woody growth as well, which helps increase the growth of grasses and forbs that grow on the prairies. If you do it every couple years, you're not really going to have a lot of shrubs. And these animals that we like to hunt ate grasses and forbs and didn't really like shrubs. So we wanted really healthy grasslands. It also, of course, rapidly recycled the nutrients that were on that top leaf litter layer, say that 10 times fast, and put those nutrients back into the soil. It was carbon recycling, it was adding potassium from those wood ashes, and it was fertilizing the prairies as well. And then, you guys have stepped outside on the pavement on a hot day, black prairie, of course, absorbs more of that solar energy more rapidly than the surrounding kind of brownish gray prairie. And then it warms up faster in the springtime. So the snow starts to melt off faster just from these growing patches of heat. It triggers the grasses, the perennials, to wake up, and it triggers seeds to start germinating sooner. So then you have a big green patch of prairie in the middle of an otherwise brown prairie. And so that helped us with the cultivation of our lands. So we weren't going and chasing down these animals necessarily, we were attracting. And there are certain seed variety, or certain seeds that actually relied on these low-intensity prairie fires to help their seeds germinate. And one of these that comes to mind is prairie turnips. Prairie turnips, Pedimonium esculenta, have a lot of different names. The Lakota call them Timsila, Blackfeet call them moss, M-A''S, and they're like a low glycemic potato, but they're a legume, so they have these seeds that grow in pods and have very thick seed coats. And if you just plant one in your garden, it has about a 5% germination rate. But if you sand it up with some sandpaper and that seed coat is broken and you plant it, it has about a 95% germination rate. So you have to break the seed coat in order for these prairie turnips to really germinate. These low-intensity prairie fires did that. If you do not have prairie fires, you have to rely on several freeze-thaw cycles to do the same thing. And so in the absence of our traditional burning practices, we've actually lost a lot of our prairie turnip populations because we haven't been able to cycle through and do that. We also see a lot of our grasses turning into shrublands and just losing a lot of the grazing potential because now there's a lot of bushes instead of grasses. Blackfeet, of course, weren't the only ones that utilized fire. As I said, tribes all over utilized fire. This is a cool study. This is tedious images from the study, but it was looking at Apache utilization of fire. So Apache people utilized fire for clearing off farmlands, for burning off undergrowth of the forests, of these pine forests, and then also higher altitude spruce and fir forests, and reducing a lot of that burnable underbrush to reduce the intensity of fires in drier years. And it was interesting because this study really looked at the frequency of how often Apache people were burning the landscape. And in order to do that, the way that the researchers were tracking this was looking at tree rings. Because the trees, especially these pines and spruce and fir that were old growth trees, were strong enough and old enough that they were withstanding these low-intensity fires. The fires were burning off things in the understory, but they weren't touching the actual trees themselves. The trees were surviving, and if you take a cross-section of those trees, you can look at the tree rings and see, oh, there was a fire in this year, and there was a fire in this year, and you can track those things. But the researchers were kind of stuck because they're like, which one of these is a lightning-caused fire, and which one of these is an Apache-caused fire? And so they had to evaluate using what knowledge they had. And so they actually used geographical data as well. And of course, when Apache people were contained to the reservation, this is really looking at Western Apache in Arizona area, but when they were contained to the reservation, fires continued at a certain frequency on those reservation lands, but continued at a different frequency in places where Apache people were no longer allowed. And so they established that frequency at which the fires are occurring outside of Apache territory where we know there is no longer any indigenous land management. That's our control. That's what we assume that we're naturally going to estimate from lightning-caused fires. And then they looked at Apache-caused fires, and they were finding that in places that Apaches were tending and burning, the frequency of fires was mean frequency interval, that's what MFI is on that axis, was somewhere around every 4 to 3 years at least, and in some places every other year they were being burnt for different purposes. So these lands were very, very intentionally tended, and this was nutrient recycling, but also this was something that was done in order to minimize the damage when those big fires did occur, so they wouldn't be able to take off and burn everything and endanger people and homes and farms and all of that. Same thing with Jemez Pueblo peoples in the Jemez Mountains. They were also very intentionally burning things away from the main village to prevent dangerous fires from damaging that village and outlying communities. So lots of cool human-fire interaction. And what I point this out is that now there's a lot of researchers and land managers that are looking at how we can utilize this indigenous knowledge of fire as a resource. Because fire technology and utilization of very intentional prescribed burns, cultural burns, good fire, can be utilized as a method, of course, of reducing fuels in very intense fires that we're facing that seem unstoppable and unfightable, but rather integrating fire into the ways in which we're managing things every single year. So there's a book by M. Cat Anderson called Tending the Wild, which specifically talks about California tribes and their land management, but there is more integration now within California land management of some of those traditional burning practices. I personally would like to see more fire used on grazing lands, on just methods for managing landscapes as well, both prairie landscapes as well as forest landscapes. But of course, these big prescribed burns and these cultural burns were outlawed because wood and lumber became commodified and considered a resource in that way, and they didn't want that lumber to be damaged by the burns from fires, even if the trees themselves were not killed. It was still something where these cultural burning practices were outlawed. Sorry, I'm just shooting laser beams instead of advancing my slides. All right, camas bakes. So I wanted to talk about camas because it's cool, nutrition, food science, all of that. But if you guys don't live in camas country, which you guys probably live here, so you don't live in camas country, it's a little bit harder to understand. What you guys do or may be able to relate to is Jerusalem artichokes or sunchokes. So sunchokes are a cool plant. They're in the sunflower family, but they're grown for their big edible root systems. They're tubers. And sunchokes, or Jerusalem artichokes, are another native plant, of course, to North America. Actually, it's interesting. Despite being from here, they have this name Jerusalem artichoke. which is fascinating to me. I was wondering why it was called that. And then I realized that the first non-native speaking peoples that gave them a name were Spanish-speaking peoples that named them, the name included the word girasol, which was faces the sun. And then an English-speaking person heard a Spanish-speaking person say girasol, and they're like, yeah, Jerusalem. So now they're Jerusalem artichokes, which is wild to me. But Jerusalem artichokes and camas have something in common, and that is that they are very high in inulin. And inulin is the reason that this plant, or Jerusalem artichokes, also have the nickname fartichokes. And that's because inulin by itself is not super digestible to our bodies, right? We have to work really hard. Unless you have really good gut enzymes, it's tough. It's tough to eat those raw. I wouldn't recommend it. So when we cook sunchokes or camas, there's a slow roasting process. You really want to cook these buggers. So traditionally for camas, which it's a lovely flower, it grows in moist mountain meadows. It is around the Pacific Northwest and in the Rockies. And Blackfeet people would wait until after this plant went to seed because all the nutrients would go back into the root, the bulb, right there. And then we would harvest it, we'd put the seeds back on the ground so it could replant them, and we would slow roast these camas bulbs in a pit roast. Okay, so I really wanted to do this, but a pit roast requires about 48 hours of slow cooking in the world's biggest underground crock pot. So I needed a team to do this because I'm not psychotic enough to stay up for 48 hours babysitting a fire. And I found out that there were some high school boys that were going to go work trail crew. And I was like, yes, high school boys. They love to stay up all night and play with fire. This is perfect. So I showed up, and I was like, all right, guys, you want to help me with this camas bake? You don't have a choice, but please help me. And these boys were super helpful, and they cleaned all these camas bulbs with me. And then we built this little pit roast. We're not trying to feed a village for an entire year. We wanted to do cool science. So we built a little pit roast in the ground, and we dug this out, and we wrapped our camas. We actually wrapped some in arrowleaf balsam root leaves, which are like the banana leaves of Indian country, and we wrapped them up. And then we wrapped some in aluminum foil because we're scientists and we needed different methods of doing this. And these boys asked me, they said, hey, can I eat this camas bulb? And I said, yeah, you can eat one. It's not going to taste like anything because when you roast it, it caramelizes the sugars, it breaks down the inulin, it ends up tasting like a cross between a sweet potato and a chestnut, but by itself it doesn't taste like anything raw. So each boy actually ate a camas bulb raw, whatever. And then I went to bed that night at my tent kind of nearby this pit roast that we were having, and they wanted to stay up and talk and take the first shift watching this fire. And I just remember from my tent, I just heard farting noises all night. It's like, yeah, makes sense. So that's how we did science. It was gas-powered science. But it was a way of, like, let's utilize this traditional technology. I don't know what person in our 18,000-year history in that country was like, yeah, this plant, don't eat it raw. But if you do X, Y, and Z and really work for it, it's like sweet and delicious. And then you can dehydrate it and you have camas for the whole year. But yeah, it was really cool, and it was cool to do a science project like this with my volunteers. All right, I can talk about buffalo all day, so that's why I saved it to the end, so I have to be calm about buffalo. So buffalo, of course, we started off this presentation and I talked about the decimation of bison populations on the prairies. But I wanted to talk about a cool study that was done on buffalo and old growth prairies. And, I should mention, this is a science presentation. I'm an academic. I'm also a Native person, and so I kind of have a love-hate relationship with peer-reviewed studies. Because I'm like, yeah, peer-reviewed research and tested things. And on the other hand, I'm like, why do I need peer-reviewed research for 14,000 years of empirical knowledge? Like, it's a whole thing. But I do appreciate having science and studies to be able to reiterate some of the things that we have known and practiced for a long time. And this is a really cool study because it took place over 30 years on some of the only old growth prairie that's really remaining on the Great Plains. So this study took place at the Konza Prairie Biological Station in Kansas, and it basically cordoned off 3 different test plots on the prairie. So you had your first test plot, which said, we will not allow any mega grazers here. Large ungulates that are going to graze the grasses. No mega grazers allowed. Next test plot, we're going to allow cattle to graze here during the growing season. Cows do not have built-in snow plows on their backs like buffalo do. They're not very good at getting through snow, so they feed them some supplemental feed in the wintertime. They're allowed on this test plot. And then finally, third test plot, buffalo, do your thing, live here year-round. We're going to study you for 30 years. And they, of course, did soil samples, and they did a lot of plant and botanical sampling and evaluated what having these animals on the prairie did to the landscape over a 30-year period. And what they found is that having the bison on the prairie more than doubled the biodiversity of native plant species as compared to the test plot that didn't have any mega grazers allowed. And that was because bison kept their heads down, but they were very selective about the foods that they were eating. They would preferentially go after the more dominant species, the grasses, and the forbs they tended to leave alone. What's interesting also is the germination rate of forbs, more seedy, herbaceous plants. Those seeds tended to increase their germination rates after passing through a bison's digestive system, whereas the grasses' seeds reduced their germination rates. The acids in a bison's stomach just kind of broke down the seed coats to an extent where they were no longer viable. What's also interesting, though, is the cows actually did increase the biodiversity of the landscape, just not to the same extent that bison did. Both bovine species were found to have enzymes in their saliva that actually increased the growth of the grass regeneration rate. So after the grasses were grazed, they would actually grow faster after being grazed than when they were just growing by themselves and weren't being touched at all. So that was specifically an enzyme within that bovine saliva. And of course this makes sense. I mean, all these plant species co-evolved with bison on the prairies around them. And some of them actually relied on this cool thing that bison do. If you guys have ever seen this before, they wallow. They roll around and they tear the heck out of the ground in these places. But they create these big bare patches of soil, and those soil patches become basically perfect bare patches of ground where certain plant species actually rely on to germinate. So that helped plant species regenerate as well. So just by reintroducing bison to the landscape, you're actually increasing the overall health of the whole prairie system. So I thought that is important as we look at bison reintroduction in different places. And bison, of course, are also nutritionally more beneficial than cattle species are. So this is my friend Elsie DeBray. Elsie, she's graduated from Stanford now, but when she was in high school, this is like an old high school picture of her, she wanted to do a cool research project for a science fair. And her dad, her family owns a buffalo ranch on Cheyenne River Reservation in South Dakota. So she wanted to do a research project looking at a lipid breakdown of buffalo meat versus cattle meat, right, versus beef. And so she did this breakdown. She basically wanted to compare grass-fed bison versus grain-fed bison versus grass-fed beef versus grain-fed beef. And she got the same cuts, and she did an analysis where she broke down the concentration, the ratio, how much fat, how many grams of fat are in each of these different meats. And what she found was that the lowest fat content was, of course, in the grass-fed bison, followed by the grain-fed bison, followed by the grass-fed beef, followed by the grain-fed beef. But she said when she looked at the actual dissolved lipids that she was looking at in test tubes and evaluating this, they looked different. When she was looking at the beef lipids, they were more white and solid. And when she was looking at the bison lipids, they were more yellowy and liquidy. They were different. So she had to figure out what they were. So she had to continue this project. And so she used a spectrometry analysis to essentially figure out where the peaks are and what type of lipids she was looking at. And what she found was a difference in the omega-6 to omega-3 ratios of these different meats. And so generally you want a lower omega-6 to omega-3 ratio, and that's considered more healthy, more beneficial to brains, more good fats. And it was that grass-fed bison that, of course, had the lowest of this ratio, and finally, grain-fed beef is way up here. So you guys can see kind of that breakdown. But it was interesting that there was just more omega-3s in the bison meat than in the beef. So it was interesting that she broke all of that down. And we know bison meat lower in fat. We've heard that many, many times before. But it was interesting that the actual types of fats were different as well, despite being very similar bovine species. And I put this slide on here kind of at the last minute because I figured I should actually talk about what I do, not just drag high schoolers into science projects in the woods. So I run a business called Indigenous, and I started this with the desire to share all of this Indigenous knowledge with people. I went to the Native Nutrition Conference, and I kept hearing from all of these folks that we need to be eating more of our traditional foods, and we need to be connecting with all of these things. But you can't just restore access to traditional foods and expect people to know how to work with them. You ever given someone a butternut squash and they're like, here's what's for dinner? If they don't know how to cook with that thing or work with these different ingredients, you're not actually going to see people eating more of those, even if you increase the accessibility of those things. So I said, we just need to start a cooking show that will teach people how to work with our traditional foods. People said, yeah, that'd be cool. I said, I'm going to do it, and I'm going to call it Indigenous. And someone said, okay, sure you are, Mariah. And then it was a challenge, so then I had to do it. So, of course, I went to school for engineering. I am not trained as a chef. I'm not trained as a filmmaker. I took a janky camera that I bought off of eBay in 2012, and I rigged up a tripod for it because I didn't have one, and I started filming things and editing it with Windows Movie Maker, which is like the most janky of all video editing software. But it's what I had, and it's what I started working with. And even from the beginning, people started tuning into my very poorly filmed cooking videos. I was lucky that I grew up in a house where I had a garden, I had wild game meat in the freezer, and my mom took an early childhood development class that said that kids that grow up cooking learn fractions better. So she was like, look, we have 4 overripe bananas instead of 2. Double the recipe. And I was like, yeah, Montessori method, like very hands-on. So I, of course, by the time I was 4, I was like, Mom, I woke up, I have a dream about these cookies. Can I make them? She's like, what's the recipe? I was like, is in my brain. She's like, write it down. So I have recipes written in marker. So I was like, I can do this. If I could make a recipe when I was 4, I can make recipes now, and I can talk to my elders, and I can share really traditional things, and I can share things made for the modern kitchen that are, elk roasts and Instapots and, air frying turkey nuggets, and like, why not? And so that's what I started doing, and it's been really amazing to be able to share that information, but also to be able to connect with other folks doing that work, because people are really interested in working more with local foods and traditional foods, whether you're native or non-native. connecting with the plants and sustainable animal foods around you. And so that's what I really love to do, and I'm fortunate that I've been able to create a space in order to share those things. So this is actually a couple of recipes I was filming at the Indigenous Food Lab in Minneapolis, and we were making a whole bunch of cooking videos and recipes and big scaled institutional recipes for school lunch programs. So that was something that was really awesome. I also put a picture of choke cherries here because choke cherries are also a great example of Indigenous science, because if you look up choke cherries in a plant identification guide, it will tell you these plants are poisonous, which isn't really true. They do have pits that contain hydrocyanic acid, so yes, cyanide. Okay, maybe don't go eating raw pits, but our Blackfeet people, as well as all of our other plains people that would eat choke cherries, would pound them all up with big heavy rocks and dehydrate them into cute little fruit patties, pits included. That dehydration process slows the enzyme activity within those choke cherries to an extent where they are no longer able to release the cyanide. So basically, it's neutralizing the cyanide in these choke cherries, and then you have lovely, delicious choke cherries, which are then sweetened by the whole dehydration process, by the way. And now they're edible, but they also have the lovely almond flavor of cyanide without the poison part. So I am pleased to see that the NRCS field guide plant identification on choke cherries now has like 2 pages of ethnobotany data on it, because there's a lot of different tribes that have used this, but it did say, this plant's poisonous for a while, so it's kind of fun. It's better now, but there's a lot of reading involved now. So I wanted to wrap things up and just thank you guys for your time, but also mention a couple of resources that I have out there. I wrote a toolkit for introducing more Indigenous foods into school meal programs, and this is available completely for free on my website. So this goes through like the whole USDA crediting process, what counts as a reimbursable meal, all of that. But there's also like 2 weeks of cycle menus for breakfasts and lunches. So if you work with any type of institution or scaled recipes or are just looking for simple, easy Indigenous recipes, there's a couple pages at the end of this book which are full of delicious kid-friendly recipes. And then also my cookbook that came out in January. It is a kids cookbook, but it's also very adult-friendly. And I'll have some for sale out in the lobby at the end for $20. So I'll be signing cookbooks. If anyone is interested in kid-friendly Indigenous food recipes, I will have that book out there as well. So I want to open things up. I know that we're doing questions, but I'm not responsible for calling on you, so hold on.
Thank you. Thank you so much, Mariah. What a terrific presentation. So many takeaways. Let's give her another round of applause. And we do have some time for some questions. I'd just like to take a moment to introduce myself. My name's Elizabeth Vogler. I'm the Festival Director with the Festival of Science, and we're just so thrilled to be kicking off the 10 best days of the year tonight. So before we take our questions, I'd just like to remind you to please take our survey when you go home. You should have received a little slip when you arrived, or perhaps, I know there's a survey screen that will be coming up in a moment here. But we really do appreciate your feedback and use it for planning future years. But with that, let's go ahead and take some questions from the audience. We have a few microphones, one on either side of the room. If you want to stand up or maybe raise your hand, we can bring the microphone to you. Oh, okay, I see one back here. Yeah, thank you. Tell us your name and go ahead with your question.
Hi, thank you so much for your wonderful presentation. My name is Gigi. Two questions. One, it looked like your high school friend, I think there was a documentary made about her. Am I mistaken? The lady who was studying beef versus...
Yeah, Elsie was on the documentary Gather.
Yeah, I think I've seen her before,
Yeah,
so
she
it was
in
very...
there. Yep.
And the second one, can you explain the science behind how smoking food kills pathogens?
Yeah. So smoking, there's a couple different ways, because of course there's cold smoking and hot smoking. Generally, I'm talking about hot smoking. So it's a process, of course, being exposed in the smoke is an area of lower humidity than often the surrounding area. So it's a drying process in that way. Often it is also raising that temperature to what's considered food safe. And then depending on that level of smoke penetration, you're getting a certain amount of creosote deposit on the food, and that's also inhibiting the growth of pathogens. I would say that a lot of smoked foods, like certain smoking methods, if you're using them to dry things completely, that will preserve foods. But just like if you smoke bacon or if you're smoking fish, those things often still have to be preserved in some way. So just that method may help kill the pathogens immediately, but not necessarily as preservation unless it's fully dehydrating.
Do we have another question in the room over here?
Also, one right over here.
Okay.
Sorry.
Oh, okay. That's okay. Go ahead.
My name's Terry White, and I'm curious about your funding sources because I'm really excited about what you're doing, and it's a long time coming to be able to have that blend of Indigenous and science, Indigenous knowledge and science knowledge coming together in ways of knowing.
Yeah, thank you. I do work for a lot of different folks, and I will work as a contractor for schools, for example. So I go and speak to different schools in Montana. I speak to different universities, but I also do private events. So I will teach virtual cooking classes on a lunch hour for different businesses. I've done law firms and big Fortune 500 companies and all sorts of very interesting things where I would never expect people to ask me to do an Indigenous cooking demo, but I do things like that. And then I do some curriculum and development work in that space. So for example, that toolkit that I had up here for school meal programs, that was funded through the Montana Partnership to End Childhood Hunger. They had me do that resource for folks and made that available for everybody. So there are certain examples like that. So really all over. And then what's interesting is on places like my website where you can go and find lots of recipes, I don't monetize them at all. So I do not have Google ads that are going to annoy you. I have no motivation to tell my whole life story while you scroll down to the recipe. It's just recipe.
Mm-hmm. So what about the sources of funding for when you were doing the science, because this was so out there? In terms of, from a science perspective, a lot of times Indigenous funding isn't there in terms of the depth that you've been able to go into.
Yeah. I personally don't do a lot of research. I have worked in some research spaces, and I have worked with a couple folks, but I haven't been the primary grant writer on that, so I can't even say that I'm the one that's going out and seeking the funding. I was doing a project with Hopa Mountain, which is a Native nonprofit training. They train nonprofits, but they themselves are a nonprofit, and we were doing a big research project, and we had an NSF grant, and it was a 3-year grant to do work with Native school meal programs and backpacks and food development and research in different communities, and that got canceled. So yeah, there's there's some different things. And also some of these projects, like going out and doing camas bakes with kids, I just wanted to go do that. So I got a call from my friends who were doing the trail program. They're like, I have some kids up here that I think would be interested. And I was like, great, I'm getting in my pickup with a shovel and I'm gonna go dig some camas and let's go. So I did that, and then I'm flying home tomorrow and I'll be working with Museum of the Rockies, which is associated with Montana State University. And they're out doing a paleontology dig. So I'm gonna be working with the kids there and talking about traditional like pemmican making and doing a workshop with that. So there's some funding through MSU, but again, I'm not their grant writer, so I don't know where their secret funding's coming from. I'm just very grateful that I get to be a part of some of that work and get to go hang out at dig sites with Blackfeet kids and make pemmican. So yeah, I wish I had more details and more creative funding explorations for you guys.
We're going to take a question that came in online, and then I think we had one over here. What is your take on the modern healthcare system coming from a Native American point of view?
Good question. IHS is going to cut me off. No. No, I think that there is momentum within the space to talk more about holistic prevention and caretaking of bodies, but I don't think that it's very incentivized. In that there are some doctors and nurses that want to talk more about prevention, but especially on a reservation level, it is often survival and funding goes towards life or limb first and not a lot of big prevention initiatives. And so those don't necessarily fall to the healthcare system. The healthcare system in a lot of our communities is kind of the last resort. So now I see our food banks and food pantries and stuff taking on nutrition education and doing that. I see 4-H programs doing cooking classes and working with all of that. So they are kind of becoming the front lines of what should probably be conversations that are happening in the doctor's office, but they're just, the resources within the healthcare system aren't present in that space. But there's definitely folks that are talking about it, but there's also still, especially in reservation communities, we have to look at alternative ways to present things besides this paternalistic viewpoint, because there have been nutritionists that come in from outside our communities and say, don't eat that, like that's bad for you. People know that fry bread is not good for them, but it's also a matter of like, how do we get the resources, whether that is, on my reservation, we have a food pharmacy prescription program. So the nutritionists at the food pantry can write prescriptions, which are basically a ticket that you can take to our local grocery stores that have signed up to this program, and you can get fruits and vegetables with those tickets. So, that is a program that exists, and she as a nutritionist is the one writing those things. But that has been some very intentional work that has taken place on the ground level in order to make that happen. So there are things that are happening, they're just not necessarily happening in the ER, right?
Did we still have a question over on this side of the room? Yes.
Go one. Is this on? Okay. I'm Sylvia, and I like to forage. And I wonder if you have any experience with two things. One is banana yucca fruit. Like, I've tried drying it, I've tried frying it, it's just kind of okay. And the other is coyote gourd. I don't know if you have that up in Montana. We have it here, and it's incredibly bitter no matter what I do to it.
I want to open this up to if anyone else in the audience has an answer. So the only thing I ever use yucca for at home, honestly, I'm like the bougie Indian that's like, I'm going to dig up the yucca and make shampoo with it, but I never quite have a shovel at the right time, and they're always so spiked. Anyway, it's a whole thing, but I can't give you any cooking advice on it. But that gives me so many great ideas to go experiment with it at home. So stay tuned. Follow me for more recipes. No. But if anyone else has advice, please jump in.
We have time for one more question. Yep.
Hi, my name is Shoshana. I'm also like a part-time forager type thing, but I had a question here. What is your favorite indigenous meal to make? The one you love to just go out and do the foraging for and come back, and because I know some of the plants, like yucca, I recommend look at African recipes for, there's a similar plant in Africa that's similar to yucca, and it's also in like a very fibrous tuber that's same thing, so I recommend go check that out.
What's the African plant called?
I'm trying to remember right now, and I can't remember. It's you just kind of, I looked it up because I saw it on a documentary, and I was like, hey, that looks like fun. And then found out, oh, I can grow that where I live, which is, I live down in Yuma, but it's very dry, arid climate, which yucca likes. But yeah, so what's your favorite meal to go do and find and make?
Cool. So one of my favorite meals, and this is kind of my comfort food, I'm a lasagna kid. So, of course, I was like, can I make lasagna with indigenous ingredients? Well, tomatoes are already, that's an indigenous ingredient. What can I use to make the rest of my lasagna? So I almost always have bison burger. Even if you don't hunt and don't have wild game meat, you can probably find bison burger in the stores. But you can make it a vegetarian lasagna too and add in all your wild greens. You could add nettles and you can add lamb's quarter and kind of make like a hearty green sauce. You can add bell peppers and cut those up, wild onions. Make like a really rich meat sauce or a meatless sauce if that's what you're doing. And then I like using, depends on the season, I can use zucchinis or I can use butternut squash. So summer squash or winter squash. And I cut those up into big rectangles. So I have noodles. And then I layer that with my meat sauce and my squash and my meat sauce and my squash. And then it's not indigenous, but I'll often top it with some mozzarella. Because I'm not layering the ricotta in there, but I do like some mozz on top. And then bee balm or wild bergamot. A lot of people grow it in their gardens, but it also grows around in some moist meadows, and it tastes just like oregano, so I'll use that to kind of season the flavor profile. And I like this one, yes, because I'm a lasagna kid, and I can eat endless amounts of lasagna, but it's also something, sorry, with the bison, it's something that, you know, has rich cultural connections to my Blackfeet side. And with the squash and the tomatoes and these garden products, they're things that come from my Chalagi ancestors. And so I like it because it's like, yes, it is the ultimate comfort food, but it is also me as a food. And so that's what I'm going to say. And it's super easy. I mean, you can literally take a can of tomato sauce, some bison, and a butternut squash and make yourself a lasagna with 3 ingredients and some spices. So yeah, super easy. The recipe's on my website.